Okay, so welcome. Welcome to my presentation where I would like to show you what we are up to in Spectoda. First, I would like to tell you some kind of like a dream or backstory how it all started. So I was dreaming about this universal controller that would create some kind of like light installations I was thinking about. And what kind of installations, you ask? Installations like, for example, for 3D printers, if they print, they will show the states of the printing. So if there's some kind of problem, it will be then it will be blink. It will be blinking in red, or some kind of installations where there will be drummers and the drummers will drum to the drums, and sensors will pick up this drumming, and interactive animation will be showing all the drums at the same time wirelessly. Or I would like to create these cool spaces with fractal animations flowing through this space, and like this interactive installations for DJs, interactive ceilings or fences, and also like battery controlled products that can synchronize wirelessly and create some kind of animations. And with this, I was thinking about creating like events where there will be like a story, animation, some kind of fun with this. Also, I would like to create create a system for controlling lights to this like industry or sports hall installation kind of stuff. Yeah, so like this warehouses or the sports hall and things like this. And in the extreme, create this interactive facades or like buildings that will monitor or like show some kind of cool things. So this is how it all started. This was my dreams, and I realized that I need to create some kind of serverless, this decentralized solution running directly on the ESPs for this interactive LED control, because this interactive LED installations are of many sizes. Yeah, they are really small. If you, for example, have one kind of lamp and you want this one lamp to interact with some kind of application or things like this, then it's only the lamp. Or in the case of the big building, it is really big, so you need to like scale it up. So with this, that's what we did. What we did in Spectoda, and now I would like to show you how it all works. So first, to this this example of the sports hall. Yeah, you have in Spectoda we have basically two components. First is an app, and then there is a controller. The controller then can have many like variants or like shapes or sizes. For example, this is the controller for controlling this industry DALI controlled light sources, and this is controller with integrated like push buttons to control stuff. And with this building blocks, you can create wireless mesh installations. So here, this is like the hall. Yeah, you have the lights, and each row of lights has its own controllers, and on the walls are these switches. And the switches and the controllers each have ESP32 built in inside. And every controller with every other controller is communicating with over ESP now in this mesh configuration like network. And then there is this application that connects via Bluetooth to the nearest controller. And as the application is connected via Bluetooth to the controller, then the application can access all other controllers via the ESP now. So this installation is local. Yeah, it works by its own. If, for example, half of the installation is without power or something happened to it, then the other half always works, because as the computing is decentralized between the ESPs, then there is no like single point of failure. So that's really cool. And with this approach, you can scale it from the really small application with only one ESP controller to really big installation, because as the number of controllers increase, then the compute also increase. So you can like scale it up with ease. And the second example about the building, we created this interactive light facade with many controllers, and this works in the same way. So the only difference is that you have controllers on the facade that do not control daily lights, like the simple like dimming, but every controller has connected addressable LED strips, and each controller then not only controls the intensity of the brightness as it is in the sports hall, but also generates animations. And this generating animations, the decentrally, in a decentralized way, in a way that this whole facade will show this one thing, is the core of the problematics we are working on in the software. So if you want to create animations, you need to render stuff decentralizedly on the controllers in a way that each controller is synchronized with the state of this like decentralized network. Yeah, so that's the problematics. All this is set up in this Spectra Studio. It is software we are developing with the intent of creating these light installations. And now I would like to show you all how it works. So with this, I would like to start in the simple example. Imagine that we have like this 8 sticks, 8 battery-powered devices that are standing on the podium, and as these players are playing, microphone is picking up the sound, and then some kind of animation is showing on the LED sticks. So that's exactly what I have here in this simulation. This is like the 8 LED strips connected to a controller. So here is the first one. So like this one. It has this S1 ESP controller, and the controller has this one port connected to it with 300 LEDs, and that's the thing you see here. And this simulated installation is then connected. Here you can see I'm connected to this installation with this studio project I have here. And with this project, I can interact with this simulated installation. So then how I can like create animations for this installation. In the core, every animation needs to be algorithmic. So with this algorithmic approach, we developed this way of like puzzle pieces to create the animations. Yeah, so for example, I can like define here that from some kind of from the time 0, yeah, from the start of the animation to infinity, yeah, so this infinity, I want to show solid color red. So I have like this simple instructions, and I can upload the instructions to this installation, and then every controller receives the instructions and shows red for the infinity of time. Yeah. Okay. Like this. Or if I switch to green, then there is this green. But I don't need to stick to this solid color. I can like create animations, yeah, because animations, that's what we like. So for example, I have like this simple animations of shot. I can switch to for example, this blue color, and if I click upload and then I unpause the timeline, yeah, then I will see that each LED strip shows this blue shot running from the start to the end in the 5 seconds interval. Yeah. Then if I shorten this interval to 1 second and I click upload, then it is faster. If I make the size bigger, then the shot is bigger, and if I change the color, then the shot is different color. And with these puzzle pieces, I have the power to create really complicated animations, because I can like snap it together in a way that it is complicated. Yeah. So for example, I will make this shot to be not so fast, and then if I disable this block, then it's like not showing here, and I can have like this rainbow cycle animation that looks like this, and I can combine these two animations in a way that if I combine it like this, yeah, so I have shot, and then I add to this rainbow cycle to it, I have like this weird mashup of the shot of the white shot running across the rainbow. But if I swap this to scale, so or like this, it's more. Then I have like this rainbow background, and as the masks in Photoshop are combined are combined, then I can combine this animation to create like this more complex animation of rainbow shot. Yeah, so in this way I can like combine the puzzle pieces together to create stuff. So if I go back to this example, I can create this animation with this loading bar. Yeah, like this loading. This loading is like animation that loads one color to another. And if I snap this animation to this layer, as I was telling you about the layers in the Photoshop, then I can apply some kind of modifiers to this layer. So for example, I want to freeze this animation in 1 second. Yeah, so this sets the time of this animation to 1 second. So it will be freezed like this. And if I freeze it in different time, then this animation will like behave differently. So then I can create a variable. Yeah, for example, like this time of freeze. Yeah, I can take this variable and paste it here. And if I write some kind of like 2 seconds to this variable, it works in the same way as the 2 seconds would be here. And with this variable, I can create some like live control. Yeah, for example, like slider here. I will name the slider like position. Yeah, position. Okay. And with the slider position, I can send the value of the slider to this variable and this variable to this set time. So now with this slider, if I switch it to timestamp, I can like set the time 2 seconds, and then this will show. So if I then tell that is from 0 seconds to 5 seconds, yeah, like this. Then if I move the slider, then the animation moves. So then if I don't if I like forget about the slider and connect it to a hardware microphone, and then the microphone is moving with the slider, then this interactive installation is showing this animation of moving the bar up and down. Yeah, so in this way, you can create really complex and interactive animations if you want. So one animation I have prepared here. So this is like a really big big project where I have this preview, this simulated installation of the facade I showed. And this facade has all of these simulated controllers. So here is like controller V1188, and yeah, like many controllers. And with this many controllers, I have this like big project. And if I hit upload, then the project is compiled, is sent to this simulated installation, and then this preview shows the way that it would look on the real thing. And you may ask, how is it all possible? And that's possible thanks to WebAssembly, because the firmware I have written in C++ for the ESP can be compiled or transpiled into WebAssembly, and this WebAssembly can then be run here in this browser. So every like this simulated controller is the instance of the WebAssembly C++ code that is running on the real ESPs. And as the ESPs are like sharing the comments and projects, uploads, and things like this wirelessly in this mesh network, here is only like simulated. So it's like also like communicating between the simulated controllers, but it's a simulation. And with this WebAssembly, I can like be sure that what shows in the WebAssembly also shows on the real stuff, because every bug that is in the real firmware will show here in the WebAssembly. So this is like the logs that are that would be shown on the ESP console here. Here the same things. So with this system, Spectra, we are working on this way of creating installations in different way that is normally thought about or thinking about, because normally you have like this server that is controlling some kind of like gateways, and the gateways are then controlling the satellite controllers. That's the stuff we are not wanting to like no. So that's not how we work. We work that all the satellite controllers have like piece of the server inside of them, and then we are making these tools like the app, the hardware, the firmware, the studio, and the cloud tools to wirelessly service all of this stuff. We are making it to create this different paradigm of creating installations for everyone. So if you want to help us create this crazy ecosystem of tools, we are right now looking for new projects we can like develop this system on. We are looking for funding, and we are looking for you, the people who are want to talk about with us. So if you look for if you look on our website, the spectra.com, you can find a Discord server, and you can come and say hi, and we can talk about the nerdy stuff. So my name is Maciej Schanek, and I thank you for watching this presentation to the end. And if you have some kind of questions, do not hesitate to go on our Discord server. Thank you.